Hello and welcome everyone. Thank you for your time. I'm happy to kick off PlumPantry's requirements, design, and planning demo. I'm Jeremiah Manio. You may have seen me briefly during our concept demo, but I'm the requirements manager for the Purple Plums. To begin our RDP demo, I'll do a rundown and elaboration of our requirements document. This document consists of the title page, table of contents, and 5 major sections that include our project introduction, our business requirements, our technical requirements, our functional requirements, our testing requirements, and also an appendix which has our functional and testing requirements matrices and our finite state machine representation diagrams along with their specific system states. To start off our requirements portion of this demonstration, let's briefly review the overall project story. For those who have not seen our initial concept demo, we envision PlumPantry to be a central hub for sharing recipes with other users online. Now, PlumPantry has various stakeholders invested in this project, including the Acme Corporation, our potential primary investor, and users who are interested in culinary activities and will utilize our application, and finally us Purple Plums, who is responsible for the fabrication and development of this project. In this section, we also acknowledge for our stakeholders that we have certain constraints and limitations, and also their impact and our mitigation tactics to hopefully avoid these limitations. Moving on, we can now talk about our development pedagogy. As you can see, we have established various models for accountability, acknowledgement, and conflict resolution. For accountability, the project team utilizes a Google Sheet time log, which is to be updated weekly, and the software ClickUp to establish accountability. Further reading can be seen in 2.21 and 2.22. For acknowledgement, our project team utilizes a team stand-up during weekly meetings to demonstrate acknowledgement on an individual, role-by-role basis. This is led by our elected project manager, Jawan. Finally, to demonstrate acknowledgement on a user basis, we utilize ClickUp status updates. For further information, please see ClickUp 2.22 and Team Standup 2.23. Finally, to ensure conflict resolution, we have a model which follows the interest-based relational approach. For more details, please follow the hyperlink under 1.5.3 Conflict Resolution Model, Interest-Based Relational Approach. Moving on to our business requirements, we have a list of our project roles, the person who has filled that position, and their responsibilities throughout the whole project. I won't bore you with these details, but I can assure you that each and every role is crucial and we're working diligently together to produce a great product for you all. Next, in our business requirements, we have established some more requirements and utilized various software to help with development logistics and code documentation. All of this will be further elaborated in this later planning section of our demonstration by Shane, so hold on to your seats, ladies and gentlemen. Finishing up our business requirements, we move on to the security section. Starting off, we have our bad client and bad developer schedule. Bad client and bad developer schedule essentially means that there are certain attacks which are drawn up by our development team in the case that our requirements are received by 1. Either a lazy developer who will do the bare minimum, or 2. A greedy client who claims some requirement is not fulfilled. The requirements manager, will collaborate with the project manager, implementation manager, and design manager to ensure that all the requirements documentation is complete and up to date. Meanwhile, the roles that don't have responsibilities or major responsibilities for the week are responsible for attacking these bad client and bad developer schedules. Finally, requirements revisions may be completed by any member of the development team, but approval cannot be granted by the author of the requirement or revision. This ensures that revision and approval duties are segregated and that not one user is creating all these requirements and testing them. Next, we have our various models for data security and privacy along with risk management. There are references in 2.6.2, 2.6.3 for further reading elaboration. We can now move on to section 3, our technical requirements. Here we have devised and listed various tools which we use to support and host our application. You'll definitely be seeing these elements throughout our project conception and development. Finally, we can finish the requirements section through sections 4, 5, and 6, functional and testing requirements along with their matrices and state diagrams. To simplify and create comprehensive requirements framework, I decided to tackle the basic functional requirements such as registration or logging in this section so that we may label and refer to them in the matrix with a specific section. Then we can create concrete, concise, and more importantly testable requirements without any ambiguity. This also makes it easier to add or delete various requirements as we go on with the development process. Now, I will go over the development process regarding these requirements by diving right into the functional and test matrix. Here we are now in our appendix and our functional requirements matrix to demonstrate our functional requirements and testing framework. Let's dive specifically into a specific functional requirement, such as, for instance, under 4.2 General Functional Requirements Recipe Management, 4.2.1 functional requirement that specifies users that are logged in can create recipe records with the specifications listed in 4.2. As a reminder, 4.2 specifies that recipes are defined as records in the database containing recipe name, ingredients, quantity, and etc. These records should successfully post to the database. This is the functional requirement. Now we can find its corresponding test in the requirements test matrix. Here we see that then our testing manager has done a great job in providing both positive and negative tests. For example, when we enter a valid recipe title, cook time, and recipe description within the allowed character limits, we have an expected outcome of a success. Meanwhile, if we enter data at the maximum allowed character limit, we have the expected outcome of failure. It is at this portion of the presentation that if we were to present physically, we were to ask an audience member for a random functional requirement for further elaboration. Since we're doing this virtually, I just decided to make a spinner that will produce a random functional requirement based on these choices. We give it a spin. Wow, shocker, 4.4 A.1. One of my favorites. We can find this in the functional requirements matrix. See the specified functional requirement that the page will feature the designated logo in a central search bar utilizing the search 4.33 function. And again, find its corresponding test in the requirements test matrix. Here we see we have various tests for this functional requirement as specified earlier. We can also see here that in our comments, Joanne Hampton has revised these functional requirements, which I have made and then has tested. These revisions are made by Joanne to ensure the separation of responsibilities regarding these requirements. I will now pass it off to him to talk about our design portion of the RDP demo.
Thank you, Jeremiah. Jeremiah worked closely with our design manager, German Nestor, and myself to develop sound requirements that accurately capture our project design expectation. I should also note that Jeremiah designed our beautiful logo you see here. I will now walk through the project design documentation for PlumPantry. In this document, we've provided introduction, an overview of system architecture, a detailed layout of the UI design, as well as a detailed specification for UI modules. We have provided the server-side design specifications for our Spring Boot application and additional technologies, which will support the backend, including the database. We've also noted source code backup design, as well as database backup designs, should note that. Next, we've covered our test design, including test design objectives, test case design examples, our full testing schedule, and test effort estimation. Finally, we have mapped out total project hours and included a breakdown and an estimation. And we've left a placeholder for our actual hours, which will be recorded at the end of our project. There's also a page to capture revision histories. Going to our architecture overview, we begin with a level 0 representation of our system. We have outlined the presentation layer, business layer, and data layer for the PlumPantry recipe sharing application. In the front end, we will have our user interface. This is where users will be able to retrieve and, once registered, create and edit recipe information. At our business layer, we have our Spring Boot application. This will supply the REST APIs, which will be consumed on the front end. Lastly, we have our data layer, which will store information for both users and recipes. We dig deeper into our front end and look closer at our user interface structure. We've provided a layout of the data flow for our entire website. This includes all of the publicly available pages, which do not require login. We've also noted some differences in the searching mechanisms between the two potential states of our system, all pages or registered pages, or rather pages for registered users. You can see from the titles of these tiles, the intended titles for some of the pages for our web interface here. And we've noted public versus private and used colors as well to help denote which pages will be inaccessible from a public view. Going deeper into our web interface, We've provided some code snippets to preview the file structure for the repo which supports our front end. I realize that this image is not too clear, so I will go to the source code. So React is again used to build user interfaces on the front end. Now, unlike Spring, this is not a framework. It's actually an open source project that was created by Facebook, and it allows us to quickly deploy front end sites using components. So in React, pages are not written in HTML, rather components are used. Components are independent reusable bits of code. You can see how they're named here, that these are elements that can be reused in different places of our site rather than developing specific pages. Additionally, these components will be then rendered using services. Services is where we would write the functions which will consume the APIs we've written on the backend. And you can see the URL for the API as configured, or the endpoint rather. Going back to our level 0 diagram, before we choose the next section of our system to present, we will simulate a random choice. Amazing. Looks like it's going to be the business layer we'll look at next. So level 1 of the business layer is comprised of our back-end Spring Boot architecture. Here you can see our Spring Boot application with an embedded Tomcat server, and then the core Spring MVC application. The Spring Boot application will sit between our desktop client in the database. Within our Spring MVC application, we have our Spring Data JPA. JPA stands for Java Persistence API, and Spring uses the built-in Java repos to store data and databases. Hibernate is an open source query service which can be used on any Java platform. So the combination of these two services allows for easy querying of data from a database. Here we can see where our RESTful web services, our REST APIs, will be written in our Spring MVC application and then consumed by the desktop client. If we move forward to level 2 of our backend design, we've provided another code snippet. Similarly, I will go to the actual source code. So this is our Spring Boot backend repo structure. We briefly talked about the MVC application earlier, but we should talk about what that framework means. With MVC, you have a controller, which is the C in MVC, and that is your input logic. You also have a model, which is your business logic, the M, and you have your view, which would be the UI logic. The MVC framework allows you to quickly develop crude web applications. Using controllers, like the user controller shown here, we are able to, here in the controller class, or controller package, we are able to write all of our crude functions. So create, get all, update, and delete. Finally, I would like to show our finite state machine representation. So here we have shown a representation of our system in all of its state and noted all of the different possible transitions and which states those transitions lead to. Additionally, we have mapped in this diagram our crude database operations. So the points in the finite state machine representation where get, post, put, and delete respectively would be called to complete certain calls to action. Here we've outlined the login and registration procedure, which is of course essential, but additionally our search query is determined on the state, or determined, I should say, our search query results are determined by the website state. So registered users, of course, will only see recipe listings from the database listed as public, whereas registered users will be able to see both private and public recipes. Additionally, they will have access to the pages to edit and create recipes. That is the end of our design documentation presentation. I'll now hand it over to our planner, Arshan, who will walk through our calendar and our strategy for planning.
Thank you, Jawan, for going over the design, and here we'll be discussing the planning of our project. So we're going to use ClickUp to plan our project. ClickUp is a tool that allows us to add our users and then create tasks where we're able to assign these tasks to people. We're able to give them due dates, priorities, status, and a time estimate of how long that task will take. And so we're able to see the calendar. So first, let's go to a date in May, which is when we're working on a preview demo, and see the task. So here we have Wednesday. On Wednesday, we can see we have to set up VS Code, which involves the task of integrating with the Git extension, set up Maven and the Spring extensions, and install Amazon Credo Java 22. And we also have the task of set up Node.js for our frontend, create the frontend project structure, and create the MongoDB database using Atlas. And so we're able to see by this little icon here that this is a subtask, and this one doesn't have it, so this is the main task with these 3 subtasks. And the yellow allows us to see a task that's in progress, and the blue-gray color shows a task that is not in progress. So by clicking on this task, for example, we can see who it's assigned to. It's assigned to these 8 people, which is our development team. So they're the ones who need to set up VS Code and start installing the software so that they're able to write the code. And so we're also able to see what specific group members are doing. For example, we have right here, let's just use myself as an example. So I have my work, I'm able to see what I have due today, which is I have to record this demo presentation, and then I have to add tasks for the video, and then I'm able to see what I have next coming up with the due dates right here, the priority flag if there is one. And so for example, I have to write the Spring Data repositories, which is under backend development, and I need to go to my weekly meetings. I need to set up VS Code also. And so here we're able to see all the tasks and they're sorted by due date. Okay, and so we're also able to see the dependencies of the task. So this little icon here is a dependency icon. And so this is a blocking dependency. If we go back here and we click on that, we're able to see that this is blocking front end and back end development because we can't start those until VS Code has been installed. Okay, so we're gonna go to our real names and we're gonna spin it and find a day that we can show as an example. So we got May 12th as an example. So let's go to May 12th and see what's going on there. So if we go to calendar and then go to May 12th, we're able to see that on that day our front-end development needs to be due and our back-end development needs to be due. So we have 8 days to do everything we need to before the preview demo is due on the 20th. So over here we're able to see that front-end development is in progress, back-end development is not in progress, and the second check-in for our final document is also due on this day. Okay, so now let's spin the wheel of names and see if we have something for anyone. Okay. Okay, so we got Jawan. As our project manager, Jawan's gonna have a lot of tasks too. But again, I just go manage users. I go to Jawan and I'm able to look at my work and I'm able to see what he has due today, what he actually has overdue, and then his next upcoming tasks. So like Jawan has the PM quizzes due. He has to set up VS Code because he's one of our developers. He needs to create the MongoDB database, and he's able to see this in order so that he understands what he has coming up. And now let's spin the thing for dependency so I can show him off for a different module. Okay, so here we have front-end development, and under front-end development we're able to see that we have front-end development is both a blocking and a waiting on. It's waiting on us to set up VS Code, create the structure, and create the GitHub repo, and we aren't able to integrate the front end and back end and test the UI components with the front end team until we complete front end development. And with our tasks, we have a time estimate, and this time estimate is the 5-hour rule because it's based on assignees. So here we have a 15-hour task, but we have 3 assignees, so it'll be 5 hours per person, which makes sure that we keep under the 5-hour rule. And here we have an example of job well done being acknowledged, where we see our document manager did a good job formatting the document, so I congratulate him on the job well done. And an example of replanning we have is that since we have these due dates and in progress, we're able to see how far along something has gone towards a due date, and if it looks like we aren't going to meet it based on the progress, then we can just move around the dates and change it so that we're able to figure out what everything's actually dependent on, so we're able to focus on our most important dependencies that unlock the most amount of tasks being able to get done, such as setting up VS Code. Thank you for watching our presentation on the requirements, design, and planning, and I hope that gave you a better understanding of our project.